Subscribe our channel, press the bell icon for latest videos.
Hi friends, here in this video we are going to see the Euler's formula for buckling of columns. So let's get started. Now here there is a column over which an axial load P is applied. The column is having diameter D and the length is L. I am assuming it to be a circular cross section. It can be anything, rectangular cross section, I section, T section, anything. Now under the action of the load, if the column is bending along the lateral direction, then it is called as buckling or crippling. And this condition should not be there in a column, and to find this buckling or crippling load we use the Euler's formula, which is given by so this is the Euler's formula. I'll explain all the terms which are used over here. P suffix E is the Euler's load, which is the Euler's buckling or crippling load, and since it is load, it would be having a unit of either Newton or it can be in terms of kilonewton. Next, pi is a constant, even E, which is the Young's modulus. For column material, this capital E value will change depending upon the material of the column, and it is having the unit Newton per mm square. Next, I minimum. It is the minimum moment of inertia, and the unit is mm raised to 4. And how to get this minimum moment of inertia? Like for a column cross section, we have two axes, that is the x-axis and the y-axis. So out of them, if we calculate Ixx and Iyy, the minimum of the values would define I minimum, because at the minimum moment of inertia, the column bends. That is, if from Ixx and Iyy, suppose Iyy value is less, then the column would be bending about the y-axis. So that is the minimum moment of inertia. And if in case of circular column or hollow circular column, both the values are same, so we have to select any one of them. Next, LE. LE is the effective length of column, or it is also called as the length of column which actually take parts in bending. Like here, for an example, if the length of column is L and suppose the entire length is bending over here, in that case this LE effective length would be equal to the length of the column. So it is defined as that length of the column which takes part in bending or which actually bends. So sometimes it may happen that the complete length of the column may not bend, but only a small portion of the length may bend. So that would be called as the effective length of the column. So by using this formula, that is Euler's formula, we can find the Euler's crippling or buckling load, and once we know the value of this load, we can avoid this load falling onto the column by dividing it with a factor of safety, and that would give us the safe load, which should be kept over the column, because Euler's or buckling load should not be kept on the column, because that would result in the buckling or crippling. So that was regarding the Euler's formula. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.